Hello everyone, we are now into the problem session 3. So let us have two problems for this session also. Problem number 1 is show that sigma minimum occurs at n naught is equal to ni under root of mu p by mu n, where n naught is concentration of electrons when you have doped it, okay? Ni is the intrinsic carrier concentration, mu p is the mobility of holes, and mu n is the mobility of electrons. How to solve this problem? You know that sigma is given by q times n mu n plus p times. We also know that concentration of holes to concentration of electrons is given by Ni square. It implies that P is given by Ni square by N. Let us substitute this equation to this. So sigma will be Q times N mu N plus Ni square by N into mu P. For this case, delta sigma, now differentiate both sides with respect to concentration of electrons. This is Q times mu n minus Ni square by N square into mu P. And when you equate it equal to 0, you will get N minimum, you will get N is equal to Ni under root of mu P by mu n. And this is nothing but N minimum. Okay, so this solves the problem. You can substitute back this N minimum in this equation, and you will see that sigma will be minimum at this plot. Okay, or you can have plot of sigma with respect to N, and you will see at this value the sigma graph will come out to the minimum value. So I am leaving this further plot to you, and you can plot in MATLAB also. Okay, let us solve next problem for this session. Problem number 2 for this session is, you have been given a silicon bar whose length is 1 micrometer, cross section area is 100 micrometer square. It is doped with antimony, and doping is 10 to the power of 17 per centimeter cube. The voltage externally applied is 10 volts. Now you have been asked to find I, that is current in the equation. Okay, you have been asked to calculate the drift velocity. So few of the things you have not covered in theory, but you are trying to cover in the problems. I think in this way you can understand things far better. I is nothing but charge that is holding by time. What is charge? That is Q. Q is, suppose I am saying this is Q times the electron concentration. Okay, this is Q is what? Where Q is total charge. T is what? The time taken by charge to move some distance. Suppose D. Okay. Q times N, that is what? Electron concentration per centimeter cube multiplied by A into L. So this is your Q. What is T? T is L divided by drift velocity. Okay. So this comes out to be Q N A V D. Okay. So remember this equation. Where Q is the electron charge, N is the concentration of electrons per centimeter cube, A is cross section area, V D is the drift velocity. Okay. The drift velocity for silicon bar is 10 to the power of 7 centimeter per second. It might be the case, this thing might be given you in the start. Okay, and assume that drift velocity is 10 to the power 7 per centimeter per second. Okay, so you have to assume that value and you have to substitute in the equation. Okay, so let us substitute back. So I you will get to be 1.6 into 10 to the power minus 19 coulomb. N is electron concentration. Since it is doped with antimony, okay, so this is 10 to the power 17 per centimeter cube, because at room temperature we assume that this entire antimony has given the electrons. Okay. Cross section area is also given to you, that is 100 micrometer square. Look, now you have to be very clear, this is the unit in micrometer square. Okay, and all the things that we are using is in centimeter. So 1 micrometer is nothing but 10 to the power 6 minus 6 meter, or you can say 10 to the power minus 4 centimeter. Okay. So 1 micrometer square, that is 10 to the power of minus 8. Okay. This is 10 to the power of minus 8. and drift velocity that is going to be 10 to the power 7 centimeter per second. So all the things you put in the same units, that is very important. When you solve it, you will get I is 0.16 ampere. So the silicon material reaches saturation velocity where E is greater than 10 to the power 5 volt per centimeter. Okay. Otherwise, it's a normal velocity. So you also remember these results. So let us stop with this, and if suppose you have any problems and doubts, you can put in the comment section. Thank you for watching.